I work for a company called Hazelcast. Who knows about Hazelcast? Well, you are in the right room, that's good. So basically, Hazelcast is a company that provides a product in-memory data grid. So basically, that's what I will show you into this talk. We also have another product that builds upon the in-memory data grid, and basically, it allows to do stream processing, and since it's in-memory, it's like super fast. Okay, let's start. Microservices. Who does microservices? With happy? Yeah. Only 2 people? 3? Ah, come on. Who doesn't do microservices? Ah, yeah, a couple of hands, that's fine. Okay, and basically, if you do microservices, I'm very lazy, so I just like copy-pasted the stuff from Martin's folder Blicky, and this is his definition of microservices, which I think is a very, very good definition. In general, everybody, oh, I need to do that, and all that, yes. Everybody does that, like componentizations, more than point, blah, 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 and then you go, and then you're organized around business capabilities. Then I lose like 20% of the people who have like microservices which are not centered around business capabilities. In general, I lose 99% here. Like most people who do microservices, they don't do microservices because they do projects. So at one point the projects end, and well, you have been doing projects probably all of your life. You know, at the end of project, it's like to production, and quality in general suffers a bit. If you have products, you reason on the long term, it's very, very different. Anyway, let's pretend that we do web services, because everybody does web services probably. Like one of the benefits of web services is scalability. Like you have this monolith, and then you scale it on multiple nodes, but every feature, even those that you don't need, they get scaled. And basically, you lose a lot. Now, if you have like microservices, you can scale only the components that you really need. Like I always use the example of e-commerce. Like you have microservices. One is for the cart, one is for the catalog, one is for the product recommendation, one is for the payment. But every commerce is just a funnel, basically. And so there are lots more people browsing your catalog than people who do payment in the end. So it doesn't make sense to scale them the same way. Then you should scale the catalog much more than the payment. So that's one of the benefits of microservices. And I've been an architect. And can you spot the differences between those two? Are there any architects in the room? No architects, or you are too shy. Probably you are too shy because you feel there is a trap. So I've been an architect, and let me tell you, this is an API call, and this is a microservice call. To architects, this is the same. To architects, this is the same. It's just a UML diagram where component A calls component B. And it's up to the developers, you, to implement it in the correct way. And if you have been a developer for some time, you know this stuff about distributed systems. Like an API call is not similar to a REST service call or to a SOAP call. They are completely different. Completely different. To architects, they might be the same, but to you, they are not. And you might know about these like fallacies of distributed computing. Does anybody of you know about that stuff? That should be printed out in your office, everywhere. Because this is all the assumptions that people, including me, make when we do distributed computing. The network is reliable. No. Like when you call an API, like when you call a real API, like you call a JVM method, then either it works or there is an exception. If there is an exception, either it bubbles up or you catch it and whatever. With the network, sometimes you make the call and nothing happens. No error, no nothing. You just must wait until the timeout. So this is probably something that you always have to remember. So my previous schema, remember, on the left is different from on the right, because on the right probably it's more something like that. And there are only 3 layers, but there can be as many layers as you want. If you go like down the abstraction layer deep enough, then there are like a lot of layers. And this is even simplified because actually it's more like that, because then afterwards you've got the response that needs to go like, and so it's not super fun. So in general, what you do is, it takes a lot of time, and that's one of the worst stuff about like the microservices hype that I see right now is, hey, we want to scale, so we implement microservices. Actually, the first step will make your architecture slower, and when I say slower, not a bit slower, but much slower, because again, when you call like a JVM method, a Java method, that it's inside the same process, it's super easy. When you need to go through all the network layers and then back again, it's like super slow. So you don't go to microservice because you want to be fast. You go to microservice because you want to be scalable, which is like completely different. And afterwards, the problem becomes the trade-off between I want fast response time and I want up-to-date data. Again, e-commerce scenario. You migrated to a microservice architecture to be scalable so you can serve your billions of customers all around the world, because, I mean, everybody has billions of customers. So that's the reason for microservices. And now, everything is so slow. Like, it's really, really, really slow. So what do? Well, you put cache. You put cache everywhere. So pricing is now cached. The price of a product is now cached. So the price, you get it very fast, but it might be out of date. And now you must think about, what's the good trade-off between the speed of the response and its freshness? And you might know that, this quote, like there are 2 hard things in computer science: naming things, cache eviction, and off-by-1 errors. There is a joke inside, but think about it. Yeah, and cache is very hard to do. Cache eviction is hard to do. Cache is hard to do. So when you do cache in general, what do? You have a hash map. Everybody does a hash map first, because, I mean, and then your hash map, it grows and grows and grows and grows, and then you've got out-of-memory errors, and then you start saying, oh, perhaps I should use a product to do caching instead. Yeah, might be a good idea, because all those problems, the product already solved it before you. So how do you evict your entities from the cache? There are multiple ways. There are time to live. There are most often used, or, sorry, less often used, or whatever. And regarding this scenario, there is something called the in-memory data grid. And basically, the in-memory data grid is a dedicated product that takes, like, hash map and distributes it. So you would only reason about, like, a hash map, but then we offer, like, distributed computing around it. Of course, it's not as simple, but to start, it's like that. So in a microservices architecture, you can use this cache in different ways. The first is, hey, who is not using Hibernate? 1, 2, 3, 4. Stop. There shouldn't be too many people, because I will talk about it. So if there are too many people, cannot talk about it anymore. So Hibernate has, we will see, as caching inside, and we can configure it to use caching solution. HTTP calls, as I mentioned, microservice architecture, e-commerce, you might want to cache some of the results to get faster response time at the cost of stale data. And then stupid stuff, probably you live in a world where everything is stateless, but if you have a customer that uses HTTP, probably there is a session somewhere, so it's not stateless anymore. And we can see how we can like become like nully stateless again or pretend to be stateless with cache. So Hibernate, I hope that even, everybody here is a Java developer? Yeah, great. So even if you don't use Hibernate, and to be honest, it has been some time since I didn't use it, you know about Hibernate, like it was one of the first object relational mapping framework. At the time, it was super great. Now it's super bad. I mean, people, they change their mind all the time. But for most scenarios, like they make the reasoning about your code much easier because, for example, I'm super bad at SQL. So I need really an expert to write the SQL, but for simple use case, I don't really want to write SQL anymore. And there is caching in Hibernate. So basically, there are two levels of caching. There are the like level 1 cache and level 2 cache. The level 1 cache is a session. So when you get results, when you make a query, when you execute a query, you get result, it gets stored in the session. The problem is if you are doing web development, the session is destroyed at the end of the HTTP request. You don't use it anymore. You don't like process the session. So you just like execute what is in the session and then it's done. And on the next request, you need to create a session again. So in web scenarios, this level 1 cache is not really super useful. However, there is a second level cache that is optional, but it can span multiple requests. And it can be integrated into different products. So the cache itself is like completely stupid. If the cache doesn't contain the key, then I will make a call to the database. I will put the key and the value in the cache. I will get returned the value. And if it's contained in the cache, then I return the value directly. Again, fast versus fresh. And how you write? Well, you just like put it in the cache and the database. How does it work? So I've created a simple Spring Boot project. Again, I know this time it's not in Kotlin, so this is like normal Java. And I have, perhaps I can show the previous version. I have configured Hazelcast. So I have configured Hazelcast in XML, but you can do the same in Java as I just like showed you just before. This is proprietary stuff. I don't want to go into the details. What you just need to understand is this. This is the Spring Boot configuration. And basically, there is nothing to do. Just use second level cache and then configure the factory class to use Hazelcast and the name of the Hazelcast instance. And that's all. At that point, I have created a controller that uses a repository. Repository is a simple Spring Data GPR repository. Fine with you? Okay. And it uses a person, and the person is just an entity. Then I'm configuring like the specific cache. The rest is just like normal stuff. And if I start that, I should have started in debug. What I will do is I will use the browser because I'm lazy. No, not this one, this one. So I will try to like watch an entity. I have activated the Hibernate statistics. So here, it tells me my statistics. It's low. That's why I told you to come in front, but sorry. Look, what I can do, because it's you, but only because it's you, I can paste it here. Better? Not better? It's very small. Nobody tells me anything. Guys, you shouldn't be so shy. I'm French. You don't need to be shy with me. Better? Great. So here, it's my first call. So basically, the cache is completely empty. It's like a completely cold cache. And so there is obviously no hits. And there is a miss that takes this time. OK? And if I make the call again, and then you will need to believe me because I don't want to. Well, I will do it anyway. I'm so good today. And now here, because it's the second time, here now I have a hit. So now the cache is good. And then if I make another request with another entity, of course, then it will again be a cache miss. So here it's a miss. And if I, like now, I have everything in the cache. I have 3 entities. And if I call number 3, it's a hit. Now everything is in the cache. So this is because Hibernate has this logic already contained, and you just need to configure Spring Boot and your own cache. It can be Hazelcast, can be your own, it can be whatever you want. But, well, here I'm using Hazelcast. There are some alternatives. Basically, here you are actually, like every time you are calling the database and through Hibernate, and it might be too slow for you for whatever reason, because you need to be really, really fast. So what you can do, and then you need to like remove Hibernate, and then you can only talk to Hazelcast, and then have some listeners that synchronously, or even better, asynchronously, they write to the database when something is changed in the key value store. Then you get something that is very, very fast. Of course, if you've got async, now there is another trade-off, that what happens if there is a failure on the node, because everything is in the memory, and because it's written asynchronously, there is no guarantee it will be in the database in the end. So depending on your use case, it might be good, might not be so good, but at least there is an alternative for that. So again, with my e-commerce architecture, that's all the service that I mentioned previously. And then the caching on the HTTP side could be manual. You could write your own cache, but you might know that there is an API for that, Jcache. Ooh. Are you already using Jcache? OK, that's fine. Jcache has a specification and has multiple implementation. And one of Jcache implementation is integrated with Spring. And Hazelcast is also a Jcache implementation. So basically, everybody is happy. We can just use Jcache. And if you need to change from whatever to Hazelcast or from Hazelcast to another cache provider, then it's easy. Let's do it. I will need to stop that, and I will need to, Jcache. So now I added like another controller, and this is a proxy controller. So basically, instead of directly going to the person controller that calls the person repository, I go to a proxy controller that uses a caching service. And this caching service is configured to use the cache itself. Also, there is like a huge difference with Hibernate is if you make like a select Joker character, everything will be cached in Hibernate. Here, it doesn't work like that. If you have a projection, basically, if you have a list, nothing gets into the cache. Every entity needs to be cached separately, whether you like it or not. So the controller is OR. I will OR 3. No, it's little OR 3. Yes. It uses the cache. No way to, well, you must trust me. Do you trust me? Told you I'm French. You shouldn't. So what we can do, so what I will be showing you, that we have a management center. I must say that right now it's not open source. You can use it if you have only one node, but there are like very heavy discussions that we should open source it. So I have no trouble like showing it to you, but just know that right now it's not open source. Yeah, something that I didn't mention that is very important, Hazelcast is open source, so, and it's not, you don't need to pay for it. So here I have this service stuff, and basically it has like one entry. It's too small. Sorry for that. Better? Okay, so basically there is no hit because, yeah, the cache was empty because I'm using another cache. And here I try to do one get and it puts one entity. So now if I try to do it again, after some point I should have two gets, yes, and still one put, but then I should have one hit. Yes, one hit. Now I've got my cache warm again. And if you go a bit further, you notice that basically you have like Jcache, and then the Springs cache, and then Hazelcast, and it's a lot of layers for nothing. So you can just like remove everything that is like Jcache specific and just use like Spring Boot's cacheable, and it will work just the same. The fun part. Yeah, so as I mentioned, like we believe our architecture is stateless. We try to make our architecture stateless, but stateless basically means that on whatever node you go, you will find your session. Because if you have like, again, an e-commerce and the cart is on the first node and the first node dies, and it will die, believe me, then when the user gets to the second node, redirected to the second node, which is working, he has no cart. If you are doing e-commerce, that doesn't work like that. So what you want is basically you want to replicate your data over all nodes so that if there is a failure, then you can get the cart session. And here is the fun part because there are no standards for that. Nothing. So you are on your own. But we have something for you. So basically, we have like several integration points. So it can be like filter-based. It can be there is a Spring Session implementation, or we also can hook, and that's what I will show you directly into the Tomcat or JT if you want. So here, what I will do is I will just put it here, checkout master. So I will have something called session data, which basically has the ID, which will be the G-session ID, and which will have a counter. And basically, when I go through the session, I increment the counter. And I have a super nice architecture, which is Docker Compose. 2 seconds, I just killed that. And basically, it has a HA proxy in front. And this HA proxy is configured so that it's completely round robin. So if there is no session replication, I should like go on one node. Then when I go to the other node, only at that time, this node will get incremented, which will be the same as this one. So I will skip 1/2. I will only increment every 2 hits when I get back to the same node. If there is session replication, I will increment at every hit. Sorry. So I have my load balancer. I have like 2 applications. This is the same application that I showed you, which has like Tomcat embedded. And I use the management center, but just for fun. And then here, I am using the Tomcat integration. So basically, it's just, you can do it in XML. I don't know what you prefer. Of course, if you have Spring Boot embedded, you don't want to like configure that in XML, but perhaps you have WAR still in your infrastructure. I don't know. Here, I'm using like simple Spring Boot. It's a bit small. Again, you don't tell me anything, but I notice it. So here, yeah, I say, hey, don't use sticky session because I will be doing round robin. So it takes a bit more time like to synchronize because now I know that since I'm not using sticky session, I need to replicate the session data at every request. And then I'm using the same Hazelcast instance. So now if I do the Docker compose up, here you see nothing, but it's not very important. I'm just doing the Docker up on this, on that. So basically that I explained everything. So now I get here. No. What does it tell me? Perhaps it's not up yet. Yes, now it's up. Yes. Always the demo syndrome. Now if I refresh, because of the load balancing, okay, I should still have 1, unless I have session replication in place. So I will show you that I have session replication in place. So every time I go to a new node, but I still have the same session data. And that is, I mean, for resiliency is really great because now you can consider your application to be like nullly stateless. You don't care about session data anymore. And here for demo purposes, I said, hey, sticky session false, just to be sure, but you can set sticky session true, which is the default. And basically for the normal use case, you always go to the same node, which is what you should do. And when it fails, then you are like redirected to another node and you still have your session data. Okay, this is basically what I wanted to show you. So, very important, scalability and performance are not the same. Like, don't do microservices because you want to be faster. If you have hundreds concurrent users, don't do that. Don't do microservices for that. 200s, 500s, no, don't do that. You just like scale normally with additional hardware and only change your architecture when really you cannot do it anymore. Again, if you go to microservices, you will actually lose performance in the first place. In order to improve performances, you should implement caching at the right place. And then at every place, you must think about the trade-off. Like, yes, it will be faster, but my data will be like local. What is that acceptable? Do I accept my pricing to be stale by 5 minutes? Might be the case. Might not be the case. It depends, and you should think about it. And Hazelcast IMDG provides like this caching as several integration point in your architecture. So as I showed you, we have like Hibernate level 2 cache. We have like JCache implementation or Spring Boot cache implementation and session replication. And thanks for your attention. You can read my blog. You can follow me on Twitter. And again, there is the repo if you want to have it. I will tweet the slides anyway, but you're welcome to take pictures. And now there is some time for question. Two talks, no questions. Guys, I'm very afraid. You don't like French people in Romania. You want me to feel bad? Or it was, thank you very much. Thank you very much.
So you're the first that I hear in a presentation saying that microservices do something bad. So congrats on the courage on saying that.
I'm not saying it's bad.
No,
I'm saying probably it's not for you. And that's the problem. I mean, it's a conference circuit, so people, they are trying to push their stuff. Probably you don't need Kubernetes either. Probably there is a lot of stuff that you don't need. Sorry, it will be recorded, but believe me. You shouldn't do it because it's hype. You should do it because you need it. Like, hey, why do you use Bazel? Because Google uses it. Oh, Google uses it, it must be so great. No, they have requirements, they have constraints, so they are doing monorepo. Probably you will fail at doing that. Or Bazel, same stuff. I mean, the funny part is we are supposed to be engineers and to be critics of every technical decision, but most of us are just like sheep following the herd. And I'm guilty as everyone. Huh? Oh, let's do that, it's so cool, everybody does it. That's just crap. So if you don't, I mean, I have another talk where I explain why you shouldn't do microservices, probably. And I can just tell you, the microservices are an organizational answer to an organizational problem. If you address it from a technical point of view, you will fail. You will fail. Basically, the only reason to do microservices is you've got too many developers working on the same code base. And then you start having like 20 or 30 feature branches at the end of each sprint. You need to merge them. Oh, no, feature branches are really bad. We should do feature flag. Yeah, now you've got 30 feature flags where there is not only like one code with one if, but like ifs that are everywhere for only one feature. I mean, again, there are issues. So in order to solve that, then you cut your code base into multiple pieces. And the fun part is at some point, the microservices proponents, they were talking about Conway's law, the law that says that your architecture will be the exact replica of your organization. And they say, oh, let's reverse Conway's law. So let's have those two pizzas team. And perhaps you have heard those two pizzas team. Who here is organized like that? Nobody. Most companies that I've been working for ages, they are still silos. So they are developers, they have product managers, they have DBAs, they have... And so this will be your microservices. So unless you change your organization, which I believe either you start from a brand new organization or you already work for an organization that is organized like that, microservices are doomed. What you can do, however, are web services, but just let's be frank, you won't have all the benefits. But still, you will have a lot of constraints, like monitoring, operation, and blah, blah, blah. So be super critical. I might say a lot of bullshit here. Of course, I am right, I know it. But be critic, because even if what I'm saying is right in my context, it might not apply in your context. And as developers or as technical leaders or whatever, you're responsible from like applying what you learned today to your context. And yeah, it might be a great fit, and then I will be happy to help you. If it doesn't fit you, then just dismiss it, that's fine. And yeah, you can live without having microservices on your resume, believe me.
So you already answered my actual question about how microservices are doing in a developer life. Do usually make the life easier or harder? But
they make life super harder. Really, I'm not kidding. Again, the microservices is just the solution to be able to work on a code base without tripping over each other's feet. How many developers do you have in a company? Like 20, 30, 50? If you start having 100, yeah, we can start talking. But before that, unless you really feel the hurt, again, I'm saying 100, perhaps at 80 you already feel that it's too much, then it's fine. But that's the only issue. And then, yes, you go to microservices, but you change your organization. And since we are all technical people here, we are not the leaders of the organization. And the biggest issue in those microservice stuff is basically, as I mentioned, there are silos. And at the top of each silo, there is a manager. Only those managers can help you change the organization. But once you have an autonomous two-pizza team, what do you do with the managers? Because, let's be frank, they are useless. But at least they can pretend that they are useful. But in a microservice organization, everybody will see that they have not their place. So basically, the only people who can help you migrating to such an organization, changing your organization, are the ones that have the most to lose. It will never happen. Never. So you can pretend you do microservices because you have two web services calling each other. You just made your life much harder without any real benefit. But just be honest about that. That's fine. Sorry, I destroyed all your hopes at the last slot of the conference.
Thank you for being frank.
Other questions? Yes.
So Hazelcast is a memory grid. And I'm curious, how does it behave in case of a network partition? And if the application has some mechanism to detect that something happened on the network? So
basically, that's a very good question. So I told you, like, Hazelcast is a distributed in-memory data grid, and so basically there is this like cap theorem. So you know about the cap theorem. So you must choose between consistency, availability, and partitioning. And basically we are using distributed systems. So basically we must be partition resistant. So we must choose between like availability and consistency. And for cache free, because like we were like our most widespread use case is caching. The important stuff for caching, is availability. So in the case of network partition, we still answer. We might give you the wrong answer, but we still answer. But that's fine. Actually, if you've got, for example, the pricing, I mean, one node might get the price from like 5 minutes ago, and another node might get the price for 3 minutes ago. That's fine. The important is we give you the price very fast, because in that case, you cache the price to answer very, very fast. Okay? Recently, we developed a CP system on top of Hazelcast. So in that case, if you use the CP system, we prefer not to answer than to give out a wrong result. So it's up to you to choose. And this system has been tested with the Jepsen suite, which is like very famous in distributed computing, and it was proved correct. So you are like really 100% sure that you will get the right result. So it's up to your configuration.
Okay, thank you.
Thank you. Other questions? Yes?
Yes, so what happens if you need to have transactional querying and transactional mining? Our cache is this sort of question.
So the question is, what happens if you need to have transactions? Well, we don't handle transactions, but you are doing microservices, so you don't need transactions. You have Sagas, right? So we don't handle transactions. You should behave like any key value store. Well, we have a lot of distributed data structure, but here it was mostly key value, so let's talk about key value. So you should handle it in the exact same way. Like the caching scenario that I propose with Hibernate, transactions I handle by Hibernate. If you want to use the alternative, where you only talk to Hazelcast, and then you have listeners that like commit and do all the stuff to the database, then of course you must change your mindset and you must handle failure gracefully, because then there are no more transactions. But again, transactions are good, but it's a trade-off. Like, it's consistent, but it's slow. So depending on your use case, transaction might be good or not. So if you need transactions, first you go to the database, and then you put like everything in Hazelcast. If you want to be very fast, then you just talk to Hazelcast, and then you only commit the data when you feel like it, and you are not sure whether, in the end, the data will be in the database. But you will be fast. There is no magical solution. You had a question.
Yeah, just like a follow-up question. So, in general, we should use Hazelcast or other similar caching systems if we want quick responses and we want to be popular, like for the partition stuff, but we should not use it if we want consistency or really up-to-date.
Okay, so the question is what the context about Hazelcast or other solutions, but mainly about Hazelcast because I'm Hazelcast. Anyway, as I mentioned just before, yes, mostly, I mean, our like legacy use case is to be available, whatever. But we have a subsystem, so it can make your use case of distributed data structure easier, even if you need consistency. Like you can check it. We have what we call a CP subsystem. So you say, oh, I want to use Hazelcast, but in the CP mode. Other questions? Consistency and partitioning. Sorry, it's about the CAP theorem. So in general, if you are doing distributed computing, P is by default because there can be partitioning because the network goes away. And so you can be only like CP, consistent, or AP and available. So you must choose. Other questions? Okay, thank you very much.